these strikers are ancient, and so sometimes it takes a minute to get a good enough spark to adequate to light the Bunsen burner. So I'm just going to put it over the burner like so. There we go. Okay, and that's my flame. I'm just trying to center the flame a little bit. Now you can already see the evolution of the ammonium chloride gas. You can see this white gas being emitted from the evaporating dish. That's the ammonium chloride subliming. And so what I'm going to do is I'm going to heat this until the gas emission, the gas evolution basically stops. And then I'm going to heat it for about 30 seconds after that, just to make sure I've driven all of it off. And after I do that, I'm going to let the evaporating dish cool for several minutes. If I take a hot evaporating dish and place it on a balance, not only do you risk burning yourself, but it can distort your measurements. When the heat interacts with the surface of the balance, bad things can happen, so we try to minimize that. So I'm going to let it cool. It takes several minutes to cool. You won't be forced to watch all that. And then we'll weigh what's left in the evaporating dish. Theoretically, what's left in the evaporating dish should be the mass of the mixture minus the mass of the ammonium chloride we used, because theoretically we're driving all of the ammonium chloride off through heating. So the only thing we've done is just heated the ammonium chloride to drive it off. The mass remaining should just be the other two components that we started with, since we've done nothing to them, and we'll see if that's the case. Okay, so after completing the first heating, I've weighed my evaporation dish, and ideally during the heating period I drove off all of the ammonium chloride. So all I have left in my first evaporating dish here is the sodium chloride and the silicon dioxide. So it's just a mixture of salt and sand. And as I stated when we were looking at the flow chart, the idea is to use the fact that salt is water soluble to separate the salt from the sand. So what I'm going to do is I'm going to take just distilled water, and I'm going to pour it into this evaporating dish with my dry mixture. And then I'm just going to decant or pour off the salt water, and that will leave the sand behind, and I'll have my salt water in this dish right here. So the manual specifies 2 or 3 rinsings with 8 milliliter aliquots of distilled water. So I'm using the same red base graduated cylinder that I used for the density video, and I just measured out my first wash. So I'm going to go ahead and pour my water into the dish, like so. Okay. Let's stir it a little bit to get as much of the salt as possible into solution. Okay, so, and now I'm just going to decant. So to do that, pour off the water, try not to get any sand. Slowly decant all the water with the salt in it off of the bed of sand. Okay, so I'm going to add my second 8 milliliter aliquot. Same thing, I'm going to stir. And decant. Again, I don't want to tilt it too far and end up with sand in my salt water. So I'm going to go through probably one more rinsing, and then I will move on with the rest of the process. So I'm going to end up heating both of these samples. I'm going to heat my salt water to force all the water to evaporate, and I'll have salt crystals left behind. And with this one, I'm going to heat it just to remove any water that's kind of been trapped with the sand after I complete my third washing. I have everything set up here so that I can run both of the heatings to finish the experiment simultaneously instead of doing everything one at a time. It just saves time that way. I have my salt water in an evaporating dish that I'm going to be heating with the Bunsen burner, just like I did during the first heating. The sand that was left behind after I decanted the salt water, I've got that on a hot plate. And so here, I'm going to evaporate the water, use a Bunsen burner to drive the water off, and what I'm left with in this evaporating dish should be just salt crystals. Here, once I've heated it thoroughly, all the remaining water should be gone, then I should have nothing but sand in this dish. Now, with the salt water here, it has a nasty tendency to splatter as it's heated, so I'm going to actually cover my evaporating dish with a watch glass, and that will allow me to avoid any kind of spattering or sample loss that might occur during the heating process. So I'm just going to place it like that, nice and covered, and we're all ready to begin the heating process. A note about heating times real quick. So the sand, it's going to be easy for me to tell when the water has been totally evaporated because it's open to air. I can see inside of it pretty well. It's easy for me to tell. Now, because the salt water is covered with a watch glass, I'm going to heat it kind of a lower flame to reduce spattering, and I'm going to heat it at least until the watch glass here looks dry. So as the heating process occurs, I'll see droplets of salt water forming on the watch glass where it's spattered and whatnot. When I look down through the watch glass and see that it's totally dry, then I'll know it's probably time to go ahead and cut the heat off. So with that, I'm going to start the heating process. Let me grab my striker, start the gas flow again. There we go. And as far as the hot plate is concerned, there's just a heat dial that I can adjust to begin heating the mixture. And if you look closer, I should say, you'll see that there's numbers all around the dial. So all you do to get a higher heat value is just to turn the dial more clockwise, and that'll raise the heat. So with that, I'm just going to let these do their thing, and when they've reached the endpoints, I'll pull both evaporating dishes off, let them cool. Ideally, this dish is only going to have salt crystals left behind in it. This dish is only going to have dry sand. So once they've cooled, I will just weigh them, get my measurements, and see if they match up. So I took the evaporating dishes with the salt crystals and the sand off of their respective heating elements. I let them cool, and then I weighed the evaporating dish, both dishes with their contents. So I'm just going to really quickly walk you through what the data sheet, where everything goes. So the mixture data, this is the first part of the data sheet. Item number 1, that's just the mass of the evaporating dish. So my first evaporating dish that I started with, I just weighed it empty and recorded that here. Now these next 3 items, 2, 3, and 4, are where I recorded my masses for the 3 components. If you remember, I showed a short excerpt with the spatula measuring out the ammonium chloride. I did that for all 3 of my components and just recorded the masses here. This is the total. Item 5 is the sum basically of 2, 3, and 4. It's the total weight of my mixture. So I just added the mass of the ammonium chloride, the mass of the sodium chloride, and the mass of the silicon dioxide, and that gives me the mass of the mixture total. Item 6 is I just added this value, my total mass of the mixture, to the mass of the evaporating dish. Okay, so item 6 is just item 5 plus item 1. It's the total weight of everything, the mixture as well as the dish that holds it. Item 7 is if I took the evaporating dish with everything in it and weighed it. So here's just the mass of the evaporating dish. This is the mass of the evaporating dish with everything in it. And if you notice, 6 and 7 theoretically should be the same, right? Because that's what 6 is as well. 6 is the mass of the mixture used, so it's all three of my components, plus the mass of the evaporating dish. But you'll notice that they don't match. When I weighed the dish with all three of its components, I didn't get the same value as if I just added all of them up on paper. And that's probably due to residual moisture. Although, because of the air currents in this room, it could also have to do with the way the balance was being affected by the currents at that particular point in time. So they don't quite match. They normally don't. And that's kind of why you're asked to do this both ways, is to illustrate that point. Down here at the bottom of the first page of your data sheet, you've got the data for the ammonium chloride. So if you remember, I heated the ammonium chloride. I got that white gaseous evolution of ammonium chloride gas, and then I removed that dish from the hot plate, or excuse me, from the heat, from the flame. So item 8, that is the mass of the evaporating dish plus the mixture. So it's the same thing as item 7. You're just bringing it down one. Item number 9 is the mass of that same dish. It's the same one I started with after heating it. So this is the mass of everything left after I drive off the ammonium chloride. This is the mass before that. This is the mass after that. So the difference between the two is the mass of ammonium chloride I lost as I heated. Okay, I started with this. I heated it to drive off the ammonium chloride and got this. And so that difference is going to give me the mass that I lost to sublimation. Second page, item number 11. So if you'll remember, I had when I went through the second heating, I had two heating elements set up. I had a Bunsen burner on the left, and I had a hot plate on the right. Over the Bunsen burner was the salt solution, and it was in an evaporating dish, and it was covered with a watch glass. So item 11 is the mass of the evaporating dish and the watch glass and the salt crystals inside of it. Right? So I took my solution, I heated it with the watch glass over top of it, and then I weighed it once all the water was driven off. Below it, item 12, this is just the mass of the dish and the watch glass. So here I've got the dish, the watch glass, and the salt crystals. Here I've just got the dish and the watch glass. So ideally, again, kind of like the last part, the difference of these two will give me the mass of just the salt crystals. Item number 14 is just the mass of the evaporating dish and the sand left inside of it. Item 15 was just the mass of the evaporating dish. Now this is the same evaporating dish I started with, and so actually this number is the same as this number, right? This was the empty evaporating dish number 1 that I started with. So this value is what you put right here. Again, this is the dish with the sand, this is the dish without the sand, and so the difference here will give me the mass of the sand. And that's how you're going to get your experimental masses for your components of your mixture.